Hi, my name is Intero. I'm a technician, and thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. In this video, I'm joined by several technicians who are doing a deep look of an Olive-5 Oxygen Concentrator. Without further ado, let's dive in.
Hi, my name is Tobias Benda. I'm a technician. So today I'm going to take you through the process of opening Olive-5 Oxygen Concentrator. So let's dive in. So with me here is the Olive-5 Oxygen Concentrator. So we are going to open it. So for us to able to open it, we need a Phillips screwdriver. So for us to access the screws, we just have to tilt it to access where the screws are put. So this Olive-5 Oxygen Concentrator has a total of 8 screws, 2, 4, 6, and 8, as you can see. So we are going to take our Phillips screwdriver and start unscrewing it. So I'm going to start with the first screw. Now, after removing the 8th one, you will see that we have now access to open the screws. So we are going to put it back into the normal position so that we can be able to remove the cover. So after removing the 8 screws at the bottom, now we are able to remove the cover, the outside cover. But before we do that, inside here there is a threaded power connector. So we just have to unthread it so that we are able to remove the outside cover. So you just have to be mindful that there is also a cable that comes on the board. So we just have to remove that so that we can have easy access to remove this outside cover. So after removing all the connections, we are going to lift this one so easily without problems. Yeah, so this is what it takes for us to open Olive-5. After doing this, I think you are now able to do whatever it takes to do the maintenance of the oxygen concentrator Olive-5.
Hello everyone, my name is Lungu, and today I'll be explaining to you and showing you where the different parts of the Olive-5 oxygen components are located. So we have Olive-5 concentrator here that we have already opened, and sometimes we know that it becomes a bit difficult to locate some of the components. So once you open up the concentrator, you can see all these components that are exposed. So the first thing that you find is the terminal block. So this is the distribution point of power. So this is the power line that comes from the main sockets and it brings power to the concentrator. So from there we can see the different components that tap power from it. So if you follow these lines closely, you'll see that we have the live and neutral line going to our control board. So the control board is responsible for controlling the valve, the oxygen monitors, and the airflow from the compressor to the Sieve Beds and then over to the patient. So from the control board, we we also have another board down here. So this board also distributes the power. So it's some of the wires are connected to the reset switch. So we have these two black and red button. So the reset switch is basically a safety feature. If you have a shorting somewhere, it trips and cuts power to the unit. We also have another board just closer to the control board. So this one has some LED lights. So we have the power light, the purity light, and the trouble light. So if you have any issues with the purity or the power, then you are going to get that light. So we also have a transformer. So the transformer is responsible for stepping down the power. So before you feed the power to the control board, it has to be stepped down, and then from there it is now connected to the control board. And then we have the valve block, which is located just under the control board. So the valve block is responsible for channeling the air. On one side, the pipe that I'm pointing out right now, so this pipe is responsible for taking air from the compressor into the valve block. And then we have these two pipes here connected to the two sieve beds. So when the control board switches between the left and the right, air will move either to the left or to the right. And then on the other side of the valve block, I'll just turn this around, we see that we also have another pipe. So this pipe is responsible for releasing the nitrogen back into the atmosphere. So from there, from the valve block, we now have pipes going to the sieve beds. So once the air has been filtered out, the highly concentrated oxygen comes out through the bottom of the sieve beds, and from there we have a pipe that gets connected to the product tank. So this is where the oxygen is stored. Some people call this the accumulator tank. From there we have a product regulator or the pressure regulator. So this one reduces the pressure from the high pressure that comes from the compressor down to something that can be given to the patient. And then after the regulator we have a bacteria filter. So this one will remove out any bacteria that might have made its way across the system. After the bacteria filter, we have a one-way valve. So this one helps to keep the flow of air into one direction, or in case you have some water coming from the humidifier bottle going back to the system, the one-way valve will help to keep it on the other side. So from the one-way valve, we see that it's connected to our flow meter. So this is where the flow meter is located, and you can make your adjustments there. And then the flow meter on the other side, if we go back we'll see that we have another pipe that now gets connected to the patient's outlet, which is on the front. So because of the heat that is generated when the machine runs, we need a way of cooling it. So we have a cooling fan there. So the cooling fan draws air on the top of it and then pushes it down towards the compressor, because that is the device that mostly produces a lot of heat. So the compressor, the way this compressor was designed was that it requires a start-run capacitor in order to keep running once it's switched on. So the start-run capacitor is located on the front of the concentrator. So if you have any issues with the compressor, then you might need to check out the start-run capacitor. And if we look at our cover here again, we also have another control board. So if you just tilt it over a bit, you'll see that we have some wires hanging in there. So those wires are connected to our display panel on the front. So this panel will show you the number of hours that the device has been running. And then we have two buttons on top. The other one is the power button, and the other one is the oxygen timing button. So if you want to set your concentrator so that it runs for a certain amount of minutes, then you use the timing button. So yeah, reaching this far, I think this is all about the components and how they are all located and connected to each other. Thank you.
Hello, my name is Sharon Ngozo. I'm a biomedical engineer. Today we'll talk about the sieve bed of an Olive-5, we'll also talk about the service gates of an Olive-5 compressor and the output pressure ranges. So let's dive in. With me here is an Olive-5 sieve bed. The bed is 410 mm long. In order to remove it from my concentrator, all you have to do is remove the fitting from both ends. So you can do it by hand, but if it's hard, you can use a tool, a regular plier. To open your sieve bed, you need some tools. So with me here is a Phillips screwdriver. We have a drilling machine with a Phillips tip. You also need a 15 mm ruler or any other ruler. The sieve bed has 4 screws at the top, and you may wish to label your top. As you can see, I have labeled my sieve bed, the top side, so that I'm not mistaken. So it has Phillips screws. So all you need, as I've said, you can use the Phillips screwdriver or the drilling machine, but it's easier using the drilling machine. So you use the drill machine to remove all the screws, but you have to be careful when removing the screws, as when you'll be removing the screws, then the spring inside will be expanding, and that makes it a certain force. So you really have to be careful. Make sure that when you're opening your sieve bed, the humidity in the environment you're doing all that has to be below 45%. For this task, you need at least 2 people, for one to hold the bed and another one to using the drilling machine. So you get your drilling machine. When unscrewing your screws, make sure that you unscrew them diagonally, because when you're screwing them, the spring inside stretches and it's easy for the spring to push the cap. Now your bed is open. You're going to remove the spring. Using the cyclic pin plier, you will remove this plastic filter. If you can manage to remove it using hands, you can do so. Before you remove the zeolite, make sure you measure the gap when you've measured the length, then you can now empty your sieve bed. So when you're done refilling your bed, you're going to close up the sieve bed. So when you're sure that your zeolite is at the length that you want it to be, you can now close the sieve bed. Make sure the plastic filter is in place. You pull back the spring. Make sure the metal cap should be in the same direction that you found it before unscrewing. done screwing the screws, make sure that when this whole process is being done, your humidity in the environment is less than 45%. That's all about Olive-5 sieve bed. Now let's dive into the compressor service kit's dimensions of an Olive-5 concentrator. Now we'll talk about the dimensions of the service kits of the compressor used in Olive-5. With me here are two different service kits. So I have an old service kit and a new service kit. So this is the one that was taken from the compressor used in Olive-5, which is ZW280F. So both of these slips and cap are ZW280. The only difference is the old one is from a ZW280F and the new one is a ZW280. So these have different dimensions. So what you need is a caliper that will help you to know the dimensions of the two sleeves. So this is how you can measure the dimensions of your sleeves. So switch on your vernier caliper, and this is how you measure the inside diameter of the sleeve. So you measure the old one, you do the same for the new one, just to be sure that they have the same inside diameter. Then we're going to measure the outside diameter. So this is how we do it. You measure the outside diameter of the old sleeve, you do the same for the new sleeve. You can also measure the thickness of your sleeves, the old one, the same for the new one. So you can also measure the height of the sleeve. So when measuring the height, we're going to do the same thing. You just have to take your sleeve. That's how we do it. Now you have to make sure that the dimensions of your old sleeve has to be the same with the new sleeve that you want to replace it with. So when we were measuring the dimensions of the two sleeves, they were a little different in terms of the thickness. So because there were a difference in the thickness, that made them to be different even in the outside diameter. So when we tried this new sleeve in Olive-280F, it was making some weird noise and the performance of the concentrator was really affected. So that made us to reuse the old sleeves. So when you're trying to reuse the old sleeves, just make sure that you clean the inside, because sometimes you might have some dirty inside. You just have to remove them using a very fine sandpaper. And once they're cleaned, you can use soapy water. When you're done cleaning, make sure that you wipe all the water, the sleeve is dry. That's when you can use them in a compressor. As for the caps, this is a 280 cap and you can use it. The dimensions are just the same as the old cap that was used in ZW280F. Now we'll talk about Olive-5 output pressure. So to measure the output pressure of a concentrator, all you need is a pressure gauge. Others, they can use an oxygen analyzer. As for me, I'll be using an ultrasonic oxygen analyzer, which is able to measure the pressure and the flow rate. So you connect the concentrator, then you switch it on. You let it run for about 2 minutes. So as I already stated, I'll be using the ultrasonic oxygen analyzer. So it has two inlets, one that measures the flow rate and the other one that measures the pressure. So I'll connect my pipe on the inlet that measures the pressure. Then I'll select the pressure. So the analyzer measures the pressure in kilopascals, and the output pressure range for an Olive-5 concentrator is 20 kilopascals to 60 kilopascals. So you have to make sure that the pressure that you're measuring has to be within the range. I will now connect my pipe to the oxygen outlet, and my pressure is getting to 45 kilopascals. So the pressure is 45 kilopascals, which is within the range of 20 kilopascals to 60 kilopascals. So this is how we measure the pressure outlet of an Olive-5 concentrator. Thank you.
Hello, my name is Intero, and I will explain about the control board found in an Olive-5 oxygen concentrator. So different oxygen concentrators have different models of control boards because the way they operate. So this one is the one that is found in an Olive-5. It's known as version 2.3. So the way this board works is quite similar to other boards. So I'll try and identify different components found on this board, and we'll see how they operate. So let's dive in. So maybe to begin with, I will start to talk about the microcontroller that is found here. So this microcontroller is known as STC microcontroller. It has a long number on it, which will appear on the screen just about now. So this is like the mother that is like controlling different or coordinating different components here on how they are going to operate, like sending out voltages at the right time and all. So moving on to like different connectors that are found here. So there's this connector. So this connector is the one that receives power from the main, like the terminal block. So AC power comes in here, and then we have a bridge rectifier here. So this is the one that converts the AC voltage that is coming in, which is like 14 volts VSC, going to the bridge rectifier, and this converts it into DC. As we know, different components here, like the microcontroller uses DC. So these are like just voltage regulators. So they have also part numbers, which are going to appear on the screen. So these are just heat sinks because there's like so much energy loss here as we are doing some voltage regulation. And we have like different capacitors just to smoothen out the voltages that are running around the board. And here you see that there's like a buzzer. So this buzzer is there just for alarms. So let's say something has gone wrong. So you will see that you're going to get some sound on the oxygen concentrator. So just to move on, here we have this chip. This is known as LM324N. So this is there to just it is like a voltage amplifier. So just to move on the connectors. So these connectors are there to supply voltage to the valve block. So there's a cable that is plugged inside here. So this cable goes to the valve blocks. So remember the valves that are operating on an Olive-5 are 12 volts. So the voltage is distributed through here. So this is a relay connected to a transistor, as well as there's like a resistor underneath here. It is good to notice that most of the components here are surface mount. So like the resistors, the diodes are the ones that you see that mostly are surface mount. So this is more like a relay module. Its purpose is that there's AC coming in. Remember, we have a compressor running on the concentrator, and the compressor uses AC. So the AC voltage comes from the terminal block inside the board here, and this relay is like a switch that is switching on so that power goes out on this connector. So this connector goes to the compressor. So in that way, we have the compressor being controlled. So maybe just to move on to like other connector here. So if I turn around the board, you see that there are also other connectors. So this connector is there for connecting the cable that is going to the power switch and as well as to the timing switch. So at some point you want your concentrator to run at a particular time, as Maui explained, and the cable that comes in here is the one that does the job. And you can see that on the pin connections there's like clock and reset and different like connectors there, connecting pins. So that's basically more about this board. So sometimes when these components are applied with so much like a higher voltage, you might actually bend them out. So we need to be careful when we're connecting to the board, or when you change a transformer. Imagine this one runs with a 14 volts transformer and then you give it a 24 volts. It means there's like some over voltage somewhere whereby you can burn out different components that can't withstand the voltage that you're giving it. So basically that is how this control board works, and thank you for watching.
My name is Francis, and I'll take you through the troubleshooting process for a solenoid valve of an Olive-5 Oxygen Concentrator. Let's dive in. So for you to be able to work on the Olive-5 valve block, you have to have the following tools. That is a screwdriver. You also need a multimeter and a 12mm spanner. So you use your screwdriver to unscrew this from where the valve is placed. So after you've done that, that's when you can safely remove the valve block from the Olive-5 Oxygen Concentrator. Of course, you also have to unscrew this. So mostly these are you can unscrew them using your bare hands. This valve block runs on 12 volts DC. So for you to troubleshoot if it is operating or not, the first thing that you can do is use your multimeter, and you can put your multimeter on VDC. So since it's 12 volts, and you can put it on 20 volts, on a maximum of 20 volts, and you should be able to measure that from your board that you're getting 12 volts. Mostly you get 11.5, so it's still within the operating range for this solenoid valve. So if you're not getting that voltage, that means the problem is with the output of the board. The board might be damaged somewhere, so you probably should replace the board. But then if you're getting the right amount of voltage, what you can do to troubleshoot if the problem rests on the valve. So this valve, each coil is rated for the 8.5 ohms. So you can use your multimeter as well. Just place it on the ohmmeter. Yeah, so I'll place it on the maximum of 200. This valve block, one coil of this is supposed to read for the 8.5 ohms and the other coil for the 8.5 ohms as well. So if you're not getting something that is for 8.5, that means there's a problem. So when I say you're not getting something that is for 8.5, I don't necessarily mean you should get for 8.5. It can be slightly less or slightly higher, then that's not a problem. But then if you get maybe, let's say 30 or 20 below or 0, that means there's a problem with the coil and you need to replace it. So I'll try to measure one coil, and I'm getting for the 8.8. So that's fine. That's for 8.7, that's still within range. And I can also try to measure the other coil, and I'm getting for the 8.7 as well. So that means both coils are okay and they don't need to be replaced. So yeah, that's on how you can troubleshoot this coil. So remember, the valve block is just the solenoid valve is just a coil of wire wound around a plunger. So when the coil gets magnetized, it attracts the plunger, which opens the doorway for the orifice. Now the air will be able to flow when the coil gets magnetized. So the same goes for the other coil as well. Yeah. So in case your coil is damaged and you need to replace it, you take your 12mm spanner and then you unscrew this. So you have to replace both coils. You unscrew that and also you unscrew the other side. And after you've done that, you can safely take them off by just pulling them up. So after you pull them up, yeah, you should have your coils removed. So notice that they have these caps. This helps to firmly tie the coils down. So when replacing as well, don't forget to put them in. So when replacing, just put them back in like that, and then yeah, and screw them back in place. Yeah, just like that. So that's on how you can replace the coil if you find out that it was damaged. And the test for you to find that it was damaged was to just check with the multimeter. So yeah, that's how you can replace it. You can replace the coil and repair your solenoid valve. Thank you.